my name is Alexandra Saunders, and today we are going to be talking about Math Practice 6, which is Attend to Precision. I'm a student at Wichita State University, and this is for the Math Investigations class. Our first example, we're going to do a couple examples about Attend to Precision before we move into the actual definition. The first example is that children are going to be more aesthetically pleased by picking a triangle that looks like this than they are a triangle that looks like this. And that's what we're talking about when we talk about attending to the precision. So students are going to understand terms that are more common to them. And so relating our teaching to terms that are more common to them is going to help them understand. A big part of attending to precision, and especially in this example, is having other students explain to other students how this is still a triangle. Because they may understand that there's three sides means that it's three sides connected means that it's a triangle, but they may not view this as a triangle. And so having another student doing a turn and talk or having another student explain why that is still a triangle will help them learn cognitively. Another example is that curriculum and teaching can be meticulous, and so it can say the same thing over and over. 2 + 2 = 4, 1 + 1 = 2, 3 + 3 = 6, and having it in that same format, the space plus space equals space, which is just, it's not helpful for their learning, but because they shouldn't mean that the equal sign necessarily means the sum or the answer. So what they need to understand is that when students first see the equal sign, it could be used in 5 = 3 + 2. So it could start with the sum, or it could be used in a context such as 9 plus blank = 8 + 2. So then you're setting two equations equal to each other. So you shouldn't just have equal sign only be showing your answer, but it can also, it just means that it's equaling something on the other side. So teachers must be clear that the signs, that sign specifically, that the equal sign specifically, signals the equality of expressions and not necessarily that it means the arrival of a sum, of an answer. So how can we use attending to the precision in the classroom? One way that we can see it, which I've already touched on a little bit, is that precise and clear communication takes years to develop and often eludes even highly educated adults. So even teachers that have been teaching for many years sometimes have trouble communicating what they're trying to get across with their students. A huge part of this is because you have to know your audience. So teachers have to take the precision, the knowledge, the terms that the kids have been grown up with and that this classroom specifically needs, and they need to use that in the classroom. And so each year it's going to be different, but each year a teacher is going to learn more about what terms work, what terms don't, and how to effectively communicate that the equal sign doesn't mean, oh, answer. It just means that they are equal. So if a teacher in curriculum serves as the native speakers of clear mathematics, young students who are the best language learners around can learn the language from them. This basically is saying that the students need to learn from each other, and their language that they're going to learn is going to impact their entire journey throughout life. So this is saying that when kids learn terms when they're younger, these are the terms they're going to take with them. And so teaching them appropriate, clear, and concise communication when they're younger is so important, not only in math, but in life. So simply, Math Practice 6 is checking your work, making sure that you as a teacher are precise, and then also having the students make sure that they are precise with their answers, that they have labels, that they know the terms that they're using. So this is the standards for mathematical practices 1 through 8, and previously I've spoken about 7, and so now we're talking about 6 today. But here in a little bit I'm going to explain how 6 and 7 relate to each other. And using these math standards in a classroom is so vital to the kids' education. So, what does this mean? Well, the textbook definition is long and lengthy, so I've put it into a couple statements that really explain what attending to precision means in a math classroom. using clear definitions in discussion with others and their own reasoning. So making sure that you're not wavering or confused about your definition. So making sure that you are concise and you understand the definition before you teach it to 20 younger kids. To state the meaning of the symbols that they choose, including using the equal sign consistently and appropriately. So this equal sign is so important that it's written directly in the Math Practice 6, that the equal sign is that important. It's made it into the standards. So that is just really awe-inspiring to me, that like explaining the equal sign in a correct way, in a concise manner, is so important that they put it in one of the 8 math practices. Attending to precision also means to carefully specify units of measure and label axes appropriately. I know that when I was in high school, if you didn't label your answer, you didn't label your axes, then it was incorrect. So really just incorporating that and making sure that they understand that even at the lowest grades, like that previous slide was saying, just if you're instilling that labeling into them at a younger age, they're going to understand it just like the back of their hand when they get up into high school and harder math classes. In elementary grades, students give carefully formulated explanations to each other. And that is just such an importance of learning to and from each other, because their turns are what they will understand, and they can maybe explain it better than the teacher will ever have a chance at explaining it. And when kids explain it to one another, they have the joy of feeling like they know something, that they can help another student, and so it's really improving their self-evaluation and their self-confidence that they know this math and they can help another student. So it's doing so many beautiful things just to help them help each other. In high school, students should have learned to examine claims and make explicit use of definitions. And so they should be able to explain what a plus sign means, what an equal sign means. They should understand these terms like the back of their hand because they would have already learned it. And they should be able to use this in higher math. Our key terms are symbols, labels, and then turn and talk I added in here. It was not a part of the Math Practice 6, but I really think that is what they were trying to get across when they said students need to learn from other students. So symbols are such as equal, less than, greater than, plus, minus, approximately, symbols that you and I know, but these students need to be taught what these mean. Labels is an item used to identify something or a descriptive term. So example, it takes 12 inches to create 1 foot. And so if you didn't have this inches or foot, it would just be, it takes 12 to make 1. That doesn't mean anything. You have to have those labels there so that the students can understand, and those students have to have those labels there so that they can learn the knowledge that they need to be learning. Turn and talk is again what I added into our key terms, because it's a teaching tool that helps other students learn information not only about each other, but about the information that the teacher is trying to get across. And it's a beautiful thing because it helps them watch, listen, be respectful listeners, and then respond in an appropriate way. Some of these kids do not even understand how to have an appropriate conversation because it hasn't been taught to them. And so this is a beautiful way to incorporate that into a math lesson. The SIOP model and how it integrates both Math Practice 6 and Math Practice 7. First, we have lesson preparation. So what is their prior knowledge? We talked about that more in Math Practice 7, but just to really understand where are they coming from and what terms do they already know. Building background would be going over key points of knowledge that will help with the lesson of the day. So understanding that these kids may need to work in separate groups and because they've built different backgrounds with math. The strategies that we've talked about are turn and talk so that they can learn appropriate vocabulary from each other, and the teacher can also incorporate that vocabulary usage in her own classroom. Practice and application, so the kids do. They do the homework assignment, they do the worksheets together, they do the game that's incorporated in this equal lesson. They actually physically do the work. The lesson delivery is making it fun and exciting. Adding pictures, adding stories to your math is just, it will make it so much more relatable to these kids. And then review and assessment. So using their prior knowledge and practice to take an assessment. So there are so many people that benefit from this SIOP model. And the SIOP model is incorporated in math classes, and so it's good to remember that. But ESOL students, I mean any student can benefit from this because it takes what they already know and builds on top of it. Just like Math Practice 7 takes what they know and builds on top of it, and Math Practice 6 really just makes it more detailed. So how they relate, for an example, we'll read a story problem. So the story problem is this. A new golf ball factory has been operating for 5 days. Each day, the factory makes 1,876 golf balls. How many golf balls did the factory make? So using Math Practice 6, they would use the terms given to determine the type of equation that should be set up. And then you would have the students converse about their answers, like how should we set it up? Is it a multiplication problem? Is it an addition problem? What numbers are sticking out to you? What labels are we going to have to put at the end of our answer? Math Practice 7 says to use the information given and complete our problem. So our information given can also be, what did we learn yesterday? Well, we learned that when you have something that only happens one day, but you want it to happen 5 days, then that's multiplication. Or it's adding 5 times over each other. And so we use multiplication to make it a faster process and a more complete process. Math Practice 7 would then have them complete the problem, and then you would actually flip back to 6 to completely finish the problem using your labels, putting golf balls back on your answer, and making sure that that whole problem was completely finished. These are my references.